Here I'm going to show you the p-value approach on examples of hypothesis tests that we've already done. Everything in black here is what we did using that first method that I showed you. The only thing new with the p-value approach is what's going to be in red. So I'm not going to go through and set up the hypotheses, go through and explain all that again. I'm just going to show you the step that's different. Okay, so in this one here, we create our hypotheses. Alpha was 0.1, so we have it labeled on our normal curve here. We calculated the test statistic to be 1.05. And what the p-value approach is saying is we want to find the probability that our test statistic is as extreme as what we got. So we're trying to find the probability that z is greater than 1.05. So using our normal curve and our tables or our calculator, we get 1 minus 0.8531, which is 0.1469. Okay, so on our curve, what we know is alpha is 0.100. And now again, the difference is before we looked up that z star value of 1.28, that's what has 10% to its right, a z-score of 1.28. Now, we're pretending that we don't know that z-score, okay, because we're not looking that up. Now what we're doing is we're going to compare alpha to our p-value. Well, the p-value of 0.1469 is larger than alpha of 0.1000. So that means if we were to label our area on here, like shade in the area that has 0.1469 to its right, all the area from here to the right, that's our p-value of 0.1469. Okay, so if you were to shade in all that area to the right, what we see now is that p-value, is greater than alpha. And that leads us to a decision to fail to reject HO, and there's not enough evidence to support the claim that the battery capacity was greater than 1.5 hours. Now, essentially what happened here was we took our sample, and our sample resulted in a mean that was 1.05 standard deviations above the mean. So it gave us a sample mean that was 1.05 above the mean. Now what's happening is we're saying that that is not too extreme. That is close enough to the center, our assumed value of 1.5 hours. That is close enough to 1.5 that it's not extreme. It's not odd. So we failed to reject HO. It looks like 1.5 could be the mean reserve capacity of all batteries. Okay, if we would have gotten a p-value of say 0.03, well, that would be farther over here to the right, and that would mean getting that sample mean was unusual. It was too extreme if the mean really was 1.5. In that case, you would reject HO and support the claim in this case. Okay, so that's using the p-value compared to alpha rather than comparing our z-scores, 1.28 to 1.05. Okay, so we're comparing this number, 0.1469, to alpha rather than 1.28 to 1.05. That's the only difference. Okay, in the second one, using the p-value approach, again, we would find the p-value, the probability that z is more extreme or greater than 2.59. We find that to be 0.0048, which is a fairly small p-value. Our alpha value was 0.01. So if we were to put that on our axes, we would see that 0.0048, that might be maybe from here over. So that means we would reject the null hypothesis because we are farther to the right of the cutoff point where alpha is. Okay, and the explanation, the same idea as the first one. Okay, and the third question here with the bank question. Okay, this one is a bit trickier because it's a two-sided test or a two-tailed test. Okay, so here we still set up our hypotheses the same way. Now we have alpha over 2, and this is what's different here. Alpha over 2 means you have 0.025 in each tail. Again, we're pretending that we don't know the 1.96. Okay, this is the p-value approach, so we haven't looked up the 1.96 values. So now we need to know, is the probability of getting a sample mean of 6.7, is that too unusual or not? So that z-score is 2.04. So the probability, now on our table, we know that we're on the z is positive now because we calculated a positive z-score. So now over here, again, we don't know that that's 1.96 because we didn't look those up with the p-value approach. So is the probability that z is greater than 2.04, is that greater than 0.025 or not? So when we find that p-value, we end up getting 1 minus 0.9793, which is 0.0207. Now this is where it's a little bit trickier. We can see that 0.0207 is less than 0.025. So we see that if we were to label that probability of 0.0207, okay, that would be to the right of the 0.025 area, okay, where that's the cutoff. So we can look at it that way and make our decision. Okay, we can reject HO. There's enough evidence to reject the claim that the mean is 6 minutes. Now that's not really the p-value though. The p-value is twice that probability because we started off by dividing alpha by 2. So you can look at it as looking at the alpha over 2 value of 0.025 and comparing it to the probability that we got. But the p-value is compared to alpha, not alpha over 2. So that probability that we got, because this was a two-sided test, if you multiply that answer, 0.027 by 2, that gives you 0.0414 for the p-value. And I know this seems a little more confusing, and this is why I don't like this doing the p-value approach as well, because this two-sided test is more confusing. But we see that p-value, when you multiply that probability that we got up here, when you multiply that by 2, that is less than alpha, 0.05. Okay, or you can look at it as dividing alpha over 2 by that right-tailed probability. Okay, either way, you end up with the same result, but you have to be careful when you talk about a p-value with a two-sided test.